Welcome guys to today's class. In today's video, we want to discuss another important experiment in practical physics, and that is experiment on determination of height of a ceiling via alternative to practical of it. So if this is your first time of coming across our video, I'm saying a warmly welcome to you. Just feel free to click subscribe, enjoy the video, click like button, yes, share to your classmates, as many persons as possible to help him or her, because we want to see alternative to practical aspect of this topic, determination of height of a ceiling. This is the experimental setup of the experiment, where you see the ceiling represented this way. Then inextensible string, it could be a thread, so to speak. If you couldn't get a string, you use a thread. Yes, then pendulum bob. Then this is the total height from the ceiling to the ground. Then this is the height from the ground to the pendulum bob, and this is the height we are to be measuring. Make sure that the height of the ground to the pendulum bob is the particular measurement given to you to be used. You understand? And so we said this, we can take thread, we can use thread here to do it. Now, look at the procedures. This diagram above shows a simple pendulum suspended from a distance h equal from the floor. The center of the bob is at distance h from the floor. As we said, center to the floor, okay? The bob is set into oscillation and the time t is 20 oscillations. And the time t, that is 20 oscillation, and the time t for 20 oscillation is taken and recorded. The procedure is repeated 4 times by varying h and obtaining the corresponding values of time t. Fig 14b and Fig 14c. This is Fig 14a. Now, when we see Fig 14b, we will see their results. They want us to extrapolate the results using the scale that will be given to us. And this is possible how to run this experiment in GCE exams and other secondary exams or secondary schools exams, so to speak. So, Fig 14b and Fig 14c shows the values of hi and ti respectively. So we'll see that fig, we'll see the figure, so to speak, where I is 1, 2, 3, 4, and 5. Determine and record the real values of hi and the corresponding values of ti. In each case, calculate the period t of the oscillation and evaluate t square. Record your readings on the table. So in this experiment, we will see the results or what they got in their experiment, the results of their experiment. And we now be able to deduce the result, bring out the result using the scale given to us. We will see how to do that. Then when we do that, we will now put inside our table of value and see the next thing to be done. Let's see the figure. Okay, so these are the results of the experiment. They are the one that provided these results for you. That is why we call it alternative to practical. Your work lies on getting the result, measuring out the measurements given to you. Read off your results out, compare it with the scale given to you, and put it on the table. 1 cm, each 1 cm gotten from this measurement represents 0.2 meter that you will get in actual measurement. So this is for the height and this for the stopwatch. Want to see how to read it off. Now, when we measured from this ground to H1, we got it to be 0.9 centimeter. Then when we measure from this ground level to H2, we got it to be 1.9 centimeter. When we also measure from this ground level to H3, we got it to be 4.2 centimeter. When we measure from ground level to this, we got it to be 5.5 centimeter. When we measured from here to what? H5. We got it to be 6.7 centimeter. So from here to here, H1, H2, H3, H4, H5. But some persons will make this mistake of writing this value inside here. This is for H1, H2, H3, H4, H5. I get what we're saying. And so what we're saying is that do not write this value here. What you do is you compare it with the scale given to you. That means the unit of this should be in meter, not in centimeter, because when we convert it, it will be in meter. How? 1 cm is to 0.2 meter. 0.9 cm will be giving you what? How many in meter? Use your calculator to press it. 0.9 times 0.2, that is 0.18. Here is 0.18. That is a meter. You do for the same one, 1.9 times what? 0.2. 1.9 times 0.2. That will be 0.38. So you are now getting the actual value, actual measurement. That is our alternative to practical. If you do not know how to what? Extrapolate your readings and compare with the scale, or you just extrapolate and carry it directly, you have failed it. Yes. The essence of alternative to practical is you are not going to perform the experiment. They will do the experiment for you, give you the result, you extrapolate, you get off your reading, read it off and package on your table. Now, for the next one, 4.2. This is 4.2, not 42, 4.2. So 4.2 times what? 0.2. 4.2 times 0.2. That gives you 0.84. Then 5.5 times 0.2. That is 1.1. Then 6.7 times 0.2. That is 1.34. So we have gotten our values of height. What about our time? All this our time. T1, T2, T3, T4, T5. A lot of students will also make mistake in this timing. Remember, it is the reading goes this way: 0, 15, 30, 45. That means 0, 5, 10, 15, 20, 25, 30, 35, 40, 41, 50, 55, 60. That means this 0 is also your 60. That is the ending point. 0 towards 60. Okay, so we can still put 60 here to tell you that 0 towards 60. Now, let me tell you something. If you don't want to make mistake in this reading of this, get the reading accuracy of this instrument. Every instrument have its reading accuracy. That is the minimum value, the minimum measurement you can get from that what reading from that measuring instrument. What do I mean? If you want to get it, if here is 30, here is 35, bah? If here is 45, here is 50. Therefore, you say 55 minus 50. 55 minus 50. All over how many small line do you see inside? 1, 2, 3, 4. When you start from the next line, you stop at the bigger line. 1, 2, 3, 4. We have 4 lines. So you say divided by 4. 5 over 4 will give me what? 5 divided by 4. 1.25. That means 1.25 seconds is the minimum value I should be getting. Now, because this falls at the third point, I will say here is 50. Now, these 3 points will be giving me 1.25 times 3. What will it give me? Whatever 1, 2, 3 gives me like 1, 2, 3. That is 3. 3 times each. Each is 1.25. 3 times each plus 50. I will write it. We'll write 1.25 times 3 plus 50. That is 53.75. We'll write here 53.75. So that is your T, first T. For the second T, it points after the 50, the first line. That means 1.25 plus 50. That is 1.250 plus 1.25. That will be giving you 51.25. 51.25. Then the next one, it falls at the third line before 45, and here is 40. So 1.25 times 3, 3.75, and here is 40, right? Here is 40 plus 40. That is 43.75. 43.75. Then in the next one, it falls at 44. No, it falls at it's 30, 35, 40. It falls at 40. 40.00. Then for the next one, it falls at the first small number before after 35. You say 35 plus 1.25, because it is only 1 after 35. So that will be giving 36.25. 36.25. Okay. Then we have gotten our T. Remember that number of oscillation is given to be 20 oscillations. Okay? So what you do now is you say that capital T is equal to small t all over n, where n is equal to 20. Here is 53.75 divided by 20. That is 2.69. 2.69. Right? 51.25 divided by what? Divided by 20 gives you 2.56. 2.56. 43.75 divided by 20 will give you 2.19. 2.19. Then 40 divided by 20 will give you 2.00. And 36.25 divided by 20 will give you 1.81. We are just putting it in 2 decimal places. Then what about your T squared? 2.69. You know, this is the approximated answer. I will advise you, once you divide this, 53.75 divided by 2, it gave us, divided by 20, 2.69, right? Okay. You now say 2.69 squared. That gives you 7.24. 7.24. 2.56 squared. That gives you 6.55. Then we now say again 2.19 squared. 2.19 squared. 4.80. 4.80. And this is 4.00. 1.81 squared. 3.28. So that is how to make your table of values for this. Yes, remember we did approximations here. Next is to go to graph plotting and answering of questions. Let's see what they ask us to plot and how to answer the question that follows it. So these are the questions that we are asked to answer in this experiment. And question number 1 says, plot a graph of H on the vertical axis and t square on the horizontal axis. Determine the slope s of the graph and the error in the slope. Very important. Find the intercept and error in the intercept, hence deduce the height of the ceiling. Okay. Find the acceleration due to gravity and its standard error. Differentiate between oscillatory and rotational motion. State two precautions and how to minimize them. Then they ask a question. The bulb of simple pendulum oscillates with an amplitude of 2 times 10 raised to power 2 meter and period of 0.53 seconds. Calculate the speed of the bulb as it passes through the equilibrium position. So these are the things we have to take care of. While we are finding the intercept and error in the intercepts, hence deducing the height of the ceiling, the information says that is coming from this formula minus h over g. Like it's obeying this formula t equals to 2 pi square root of capital H minus h over g, where the capital H will be the height of the ceiling and the small h is what we plotted against t square. So we need to have this in mind. So we are going into the graph plotting, hence answer the following question. Let's go into the graph plotting.